I didn't really find much actual footage of the tsunami while doing research for this episode. Maybe it's out there, but I didn't come across it. But you do come across eyewitness accounts. So let's see a couple more of those. The tidal wave knocked down many of us. It caused extensive damage to our houses. I mean, look at this guy. I'm pretty sure this footage was shot after the event. And remember what it talked about, what happens to you when you get caught in a tsunami wave. And it doesn't even have to be that big. You know, you can have 5 feet of water moving rapidly, filled with debris. And if you get stuck in that water, you can be killed not only by drowning, but also just by being impaled by things. Huge pieces of buildings, logs, everything that just gets swept up, batters the you-know-what out of you. And that's what happened to this guy.
Something yang peruk, ang pundahan ko raan, may plalukin nakatuktok. So, may plasabos loinday, so, lusawe, big man and stop.
This channel is Gadia Robert. This is from 12 years ago. Wave Atape Tsunami, 1998 is the title.
I think it was before the second earthquake that there was this terrible noise. And lots of the village people came out because we were quite close to their villages, their homes. And we're all just standing there in silence, just wondering what on earth this noise was. I've never heard anything like it before. And then the people started running down towards the beach just to see what it was. And I don't know what it was. Something in me just said it's a tidal wave. I don't know why, because I've never been through a tidal wave before. And it was just this horrific noise, and I just said, it's a tidal wave. After that, things happened so fast.
If you do research on tsunamis and you look at people who are interviewed about what happened, oftentimes they refer to it as a tidal wave. And I think in a lot of people's minds, tidal wave and tsunami are kind of the same thing, but they aren't, in fact. Just so you guys know, tsunamis are massive, destructive, unpredictable waves caused by seismic activity, earthquake, landslides. Tidal waves are predictable daily or monthly surges in water level caused by the gravitational pull of the moon and the sun. While tidal wave was formerly used for tsunamis, it is scientifically inaccurate. So there is a difference between tidal and tsunami, although in cases like this, it really doesn't matter because you know what they're talking about. Huge wave coming from the ocean. Now let's go to another animation from the channel Mensen Boaz, Papua New Guinea Tsunami 1988. And this will visually explain what happened. Okay, you see this right here? Remember the one person was describing? They were out there fishing, and all of a sudden they saw this boom, this big like explosion, and a huge fountain of water, a huge explosion of water came out. I, in fact, did read that some of the locals who saw this thought that it was a bomb, and that there was actually people saying, oh, a bomb caused this tsunami. But as that chunk slides down, see, it draws down the water first. So, and the drawing down of that water possibly is what releases the gases, right? Tsunamis are terrifying because not only is the wave part of it scary, but there's all this weird stuff that happens because of the tsunami that doesn't seem to really happen normally. I mean, I guess this stuff does, I guess gas is released all the time from the bottom of the ocean, but in the context of like a human disaster, it does seem like in this case, there's just a lot of secondary effects that are strange. A question I would have would be, how far down did the slumping of this huge chunk of sediment, this landslide, this submarine landslide, how far did the ocean go down? Imagine if you were in a boat right here, fishing or doing something, when this thing kicked off underneath you. What would you see? All of a sudden, all around you, right, in a great big circle, you'd see the ocean start to suddenly go up higher, and then you would be sinking down. And then at one point, you would literally be in the middle of a giant bowl. How deep did that bowl get? And then as the bottom of the bowl snaps back up, boom, you have this huge plume of water. Is that insane or what? I mean, it goes up and down multiple times. before inundating the coast. So scientists studying tsunamis had to figure out why a relatively moderate earthquake resulted in such a big tsunami and why it was so localized, right? If you remember during the 2004 tsunami, there was video just pouring in from all these different countries, right? Indonesia, Thailand. It's like this thing just hit everywhere, right? And I think that was because the tsunamigenic force, tsunamigenic, that was the word of the day yesterday, happened over a long distance. So a huge chunk of the plate. I can't remember if it went up or down. Did it go down? Let's just say it went up, right? And it was over a long distance, suddenly like that. And then you get these huge waves, whereas this one, although it hit an area, a large area on a human scale, it was somewhat localized, which was kind of a clue to some of these researchers who started to think, hey, maybe this thing was an underwater landslide. So where does your mind go from there? Well, it goes to, well, if this underwater landslide happened here, certainly there's going to be other places where this could happen, right? And also remember that underwater landslides can happen without an earthquake. Earthquake, you feel it, even a relatively low-level earthquake. Oh, geez, watch out for a tsunami. You would know that now, right? But what if there's no earthquake? What if all of a sudden you're at the beach one day in a tectonically inactive part of the country, like here in the United States, where I live, on the eastern seaboard, it is relatively tectonically inactive. There was an earthquake here when my son was very young. I remember I was sitting one day doing something, I forget what it was, and all of a sudden there was the whole house started to move, like a rumble, and then the whole house started to shake. Not violently like you see in some of these insane videos. It was like this, right? All of a sudden, the whole thing started doing this. And I was like, what is, of course, I look outside. Is there a big truck going by? Because sometimes trucks go by, they rattle the windows and stuff like that. No. And it only lasted for 5 seconds. It was the weirdest sensation I've ever felt. Up until that point, I really hadn't been in an earthquake big enough to really feel it. All of a sudden, the whole house started doing this. And what struck me as so weird was it wasn't just a vibration coming from the outside it was the entire house. I mean, I was like, whoa. I went in the other room and I checked on my son. And then I went online and I was like, what, I said, earthquake, East Coast, boom. Sure enough, right then, that was that earthquake. I forget what year that was. It was quite a while ago. And that was like a 4.0. I mean, this was a minor earthquake. And that's the kind of earthquakes I think we get around here. I guess you could call them weak. But you have to remember that even during that weak earthquake, the entire east coast of the United States was moving at the same time, right? So yeah, it's not like that. It's kind of gentle. It's kind of rocking, but it's the entire side of the country. That's how strong. And that's when the first time I was like beginning to really comprehend how insanely strong these earthquakes are. And if you're out there, if you've actually lived through a severe earthquake, leave a comment and let me know what your takeaway was. When the entire earth starts to move, it's like a feeling. It's like no feeling you've ever felt before. So these tsunamis that are created by underwater landslides, they do pose a significant, often unpredictable threat to coastal communities, accounting for nearly 5% of recorded tsunamis, with higher impact in areas with steep slopes. What are the key hotspots? Include the U.S. continental margins. That's here. That's the East Coast. There was one in the Norwegian Sea called the Storega Slide, and this happened like 6,000 years ago. This was before recorded history. There was one in 1929 on the Grand Banks. There is a volcano. I want to say it's in the Portuguese islands, but I'm not sure about that. There's some islands there off the coast of northern Africa and Portugal where there's essentially half of a volcano is kind of perched, ready to slip into the ocean. And I can't remember what it's called, but you can look it up online. And basically that situation is that if this thing detaches and slides into the ocean, it will create a tsunami way over there on the other side of the Atlantic Ocean. And that tsunami will come the whole way over, right? It'll hit that area over there. But this chunk of a mountain of a volcano is so huge that, boom, when it hits, it's going to send a tsunami, a huge tsunami. And the entire East Coast of the United States would be affected. Now, that's a subaerial landslide. So that's a landslide above the water, slumping down into the water. What we're talking about today is a completely submarine landslide. Let's quick look at a paper here titled A Review of Approaches for Submarine Landslide Tsunami Hazard Identification and Assessment. And let's look at the highlights that I came up with on this one. Tsunami risk will increase along with growing population concentrations in coastal regions, particularly within the low elevation coastal zone, altitude below 10 meters, so 33 feet and below. It was estimated that 625 million people lived below 10 meters elevation in 2000. Okay. What's the population right now in 2026? Isn't it like, I want to say 8 or 9 billion? I don't know. That's a good question. What is the global population right now? Leave in the comments if you know off the top of your head. But it was estimated in the year 2000 that 625 million people lived along the coast somewhere on Earth below 30 feet of elevation. That's a lot of people. And this number is forecast to reach as many as 949, so a billion people by 2030. 2030 is only 4 years away, fellow time travelers. Yeah, so in 4 years, we could have almost a billion people living around the world next to the ocean on terrain that is 30 feet or less in height above the sea level. And most of these people will be living in underdeveloped countries, right? So kind of like what happened there in Papua New Guinea, I don't think that part of the island is necessarily developed. Obviously, people did come, but it was 40 hours after the actual tsunami hit. The waves hit, the 3 or 4 waves hit, until a concerted effort actually came in from the outside to start helping these people. And that was just one, 10, 15, 20 kilometer strip on the coast of Papua New Guinea. And that was a kind of a localized event. Imagine a tsunami on the scale of the 2004 tsunami. Historically, the focus of tsunami research has been on earthquake sources, as they cause around 80% of the known tsunamis that happen globally. Landslides are the second most frequent source of tsunamis globally, responsible for about 4.8% of reported and or recorded tsunamis. Now, that's a small percentage, but that's still a lot. And again, the number of people that could be affected by these is huge. Tsunamigenic landslides can occur in different settings, including entirely underwater, partially submerged, or initiating terrestrially and impacting a water body such as a sea, a fjord, or a lake. And that's what I was talking about in the situation with the volcano that's going to slide into the ocean over on the other side of the pond there. The characteristics of the hazards presented by submarine landslide tsunamis include: number 1, rapid arrival time or short tsunami travel time, due to high potential for submarine landslides to originate on continental slopes close to coastlines. So these things can arrive faster than a typical tsunami. Number 2, highly directional tsunami waves, which can lead to focused corridors of waves impacting sections of coastline. Highly directional. Okay, so not broad spread out. It's coming this way and it's coming for you. 3, large wave amplitudes that can locally exceed those from co-seismic tsunamis, as submarine landslides may displace the water column vertically many times more in comparison to fault ruptures. This effect can lead to locally extreme run-up heights at nearby coasts. So the landslide can move the water column under the right conditions more than a tectonically or an earthquake originating tsunami. 4, lack of forewarning. While key modern examples of submarine landslide tsunami have involved submarine landslides triggered by earthquakes, there are a few ways to realize that a tsunamigenic submarine landslide has been generated in real time, leading to unexpected wave arrival at coastlines. There is no warning. And I think I mentioned that earlier, that These landslides can occur without the help of an earthquake. While earthquakes often set them off, and even low-powered earthquakes can set them off, sometimes there's no earthquake at all, and these things just happen. And what kind of warning would you get? Nobody's picking up the tremor, the shaking of the earth. Nobody picks that because it doesn't happen. Compared to seismic ruptures, submarine landslides typically produce relatively short wavelength, highly dispersive waves, primarily because of radial spreading, right? That was that, like in those animations, remember? A submarine landslide moves less material globally than fault rupture. However, it can locally displace the seafloor many times more vertically than a fault displacement, resulting in comparable amount of tsunami energy. The main component of impulse wave generation occurs as the water surface is drawn down above the site of the submarine landslide, right? Remember, imagine you're sitting in a boat. Whoa! Followed by smaller trailing waves propagating radially out towards away from the source area. Both the initial acceleration and maximum velocity achieved by a submarine landslide are governed by material density, submergence depth, and slope angle. There's different factors that go into the ultimate power of a submarine landslide. That's all they're saying there. The 1929 7.2 earthquake on the southwestern Grand Banks of Newfoundland was followed by waves with a maximum run-up height of 13 meters at the Newfoundland coast, resulting in 28 deaths and severe damage to property and infrastructure, right? It's another well-known example of landslide tsunamis. The most intensely studied prehistoric tsunamigenic submarine landslide is the circa 8150 BP before present, okay, 8,000 years ago, Storega slide of western Norway. The slide mobilized 3,200 cubic kilometers of material. Let's say that again. 3,200 cubic kilometers. And the waves created by the Norway Storega landslide that took place approximately 8,000 years ago, they're thinking these waves were 20 meters high, so 65 feet-ish. Various preconditioning factors may prime slopes for failure, including overpressure due to rapid sediment deposition, sea level change, and weak layers within the sediment. And when these slopes are primed for failure, everything's set up for these things to fail and start sliding, an earthquake is a likely trigger mechanism. However, heavy rainfalls or anthropogenic origin human-induced landslides are also implicated. And as if that wasn't enough, we also note direct evidence of submarine landslides triggered by storms. For example, 14 submarine landslides were triggered during Typhoon Morakot in Taiwan in 2009. So if you get a storm big enough where it's moving the water and it's triggering stuff sliding down slopes, you know, deep beneath the surface. So storms can also trigger these things, which likewise trigger tsunamis. So that's it. 1998, Papua New Guinea underwater landslide triggered massive tsunami waves, taking the lives of approximately 2,200 Papua New Guineans, destroying entire villages. Interestingly enough, I came across an article right at the end of my research titled "Skull Found in Papua New Guinea Was World's Oldest Tsunami Victim." A mysterious partial skull unearthed in Papua New Guinea in 1929 that once was thought to belong to an extinct human species now turns out to have another unique distinction. Scientists believe it belongs to the oldest known human tsunami victim. The researchers said that new examinations of the sediments where the 6,000-year-old skull was found detected hallmarks of a tsunami with a composition remarkably similar to the remnants of a deadly 1998 tsunami that lashed the same area. The skull was initially mistaken for a species called Homo erectus that died out about 140,000 years ago. Later scientific dating revealed it to be 6,000 years old, not 140,000, but 6,000. There's a picture of the skull. The scientists examined geological deposits at the riverbed site where the skull was found, and they identified clear signs of tsunami activity. So there you have it. These things have been happening. as long as we've been on the planet as a species, right? Ancient tsunamis caused by ancient landslides, killing people, dragging bodies into the lagoon, doing the same thing that they do now when they hit. But think of all those tsunamis that have hit over the years, over the tens and hundreds of thousands of years. All those tsunamis that have hit and visited destruction upon us and the land that we'll never know about. Now, there are scientists who specialize in studying paleo tsunamis, which are ancient tsunamis, and they can discover and spot these old tsunamis. I've read a few articles about that too. That's a whole other thing, right? You could do an episode on that alone, paleo tsunamis. So it is a threat, and it's going to stay with us. And the more they find out about it, obviously, the better they can predict. One of the things that happened with this tsunami in 1998 in Papua New Guinea was that there was no tsunami threat issued because the quake fell well below the level that was usually associated with tsunami generating earthquakes. And by the time they saw that weird red flashing black helicopter sounding wave head up on the horizon, it was too late. But now they do know not only why that tsunami appeared, but how and where it originated from, as we showed in the material in today's episode. Hope you had a good time. I know I surely did. Hit subscribe, ring my bell, follow me on all the platforms. This is Brett for Topo Ranger, and I'll see everyone in the next episode.